Hello friends, welcome to EHL. In this video we discuss about cost optimization ideas for sheet metal parts and bus bars. Here we have few small ideas which can be used in general for any of the parts as a concept. Friends,
Subscribe and keep bell icon.
so this is the first idea that standardizing the thickness of sheet metal. So let's say for example, there are 90% parts with 3 mm thickness and 10% with 2 mm thickness. Then we can make all of 3 mm. Why? Because if you make 3 mm parts separately and 2 mm parts separately, it will generate a scrap material. So let's say this is the punching layout, and here you have to cut two parts from these sheets. Then this area will be scrapped, or this area will be scrapped. So this is the cutout area of this part. So if the part is smaller than this part, 2 mm part is smaller than this part, then we can use this area and we can lay another part inside it, so that we can use this scrap material, so that will reduce the scrap of this part. So for this we need to check the size of the part, whether this can be fitted into the scrap material in the punching layout, and the criticality of component also we need to check, whether 3 mm can be used instead of 2 mm in the assembly or not. So this is the general concept that we can use for standardizing the thickness of the sheet metal in order to reduce the cost, because the supplier has to maintain the stock for two different thickness. If you are using 3 mm and 2 mm, this is for example, it could be 3 mm also and 4 mm or 6 mm also, whatever the thickness is. So if we standardize the thickness into less variants, so it may be also possible that we have 5 or 6 different thickness variations within the product or assembly. Then we can reduce it to 2 or 3. We can optimize like that also. That will reduce your scrap cost substantially. Then changing the material for non-structural part. For example, there are parts which are not for structural purpose. Those parts having a less requirements for the strength, and we can use less costly material. Here we have one example where we have structural parts made of aluminum ALMG3, which is also equivalent to aluminum 5052, which is very costly material. And in that we have some brackets and covers, like air guides and some other brackets, which are not the part of structural member and which are not required for the strength purpose. So for those parts, we have removed that material and replace it with the commercial grade or 200 series, or even different commercial grade aluminum, which is one third of the cost of this aluminum. Or and for other covers which are only for transportation purpose, means after reaching the destinations they used to remove those covers and replace it with the aluminum parts of their own design. So in that case we have used MDF or other low cost material like plastic, so that the cost can be reduced. Here what we need to check is, we need to check FEA report for low grade material, whether the required strength can be achieved or not, or what will be the stress generated in those areas. Even though it is not structural part, we need to check in overall FEA report, and also the volume of material for non-structural part, because if the volume is less, then it will be useless to replace this part. So the whole game of cost optimization is both material as well as volume. Then by reducing the number of bends and cutout areas, for example, there are parts with more bends Then we can simplify the parts to reduce the band number of bands. Also we can reduce the number of cutout areas, because each band will add the cost in the part, and also the cutout area will increase the cutting length, that will also add in the cost. So here we need to check the need of the band or cutout, and then FEA report for the low grade material also. Here there is a one example that part, this is the part with almost 8 bands. Here you can see there are 8 bands here, and here we can replace it with 4 bands only. Sorry, it is wrong. So we can replace it with 4 bands, and then we can check this whether this will be sufficient or not in FEA report. And there are sometimes location where sometimes we don't need this, but initially it was added due to some forecast or some future point of view. And if later on in the design if it is not needed, then we can reduce it also. So sometimes design takes over a period of time for developing prototype, and during that sometimes the requirement is not clear and we add on uh, provisions, and which does not need later on. So that kind of things we can reduce it. Here also there is a one example, there is a one part with these cutouts. These cutouts are mainly used for fixing the cable ties. If we lay the cables from over this, and then we can fix it with the cable tie. Also we can fix some brackets over here. And during the initial phase of the design, if we don't know where the cable will come or where the bracket will come, then we provide number of cutouts, and then we can add wherever we require during the prototype assembly. But later on, if we are clear that we only need these 6 cutouts, we don't need other cutouts in the future also, then we can optimize it and we can reduce it to 6 cutouts only. That will reduce the cost of cutting these parts. So these are the general few concepts and ideas that can be used for the cost optimization that I have presented. There are even more ideas which we can use it. So friends, I hope you will like this video. Thank you very much and happy learning.